Morning Year 8. We're going to look at constructing two more different kinds of triangles today, and today we're going to use a ruler again, and we're not going to use a protractor, but we are going to use a pair of compasses. So if you haven't got your pair of compasses with you right now, can you go away and see if you can find them and then come back to the video. So just quickly pause the video and get yourself sorted with a compass. Okay, so the first sort of triangle we're going to look at today is a side, side, side triangle. And no prizes for guessing that this is a triangle where you've been given all three sides but none of the angles. And the clue to not being using a protractor and using compasses instead is because there is no angles given in the question, just sides. So let's have a quick go at doing a question. My camera seems to have gone off for some reason. No, it is still there. There we go. So let's just quickly try an example. So here's our example we're going to try. It says construct the triangle ABC so that AB is 6, AC is 5, and the length of BC is 4. Okay, so with this sort of question, in general, I pick the longest one for my base. It doesn't matter which one you pick for your base. If you pick a different one to what people expect, that's fine. The triangles will still be congruent to each other. In other words, the same as long as you rotate them. Or flip them. So I'm going to start by drawing my base. I'm going to use, well, I've already put my pencil and my compass, it doesn't matter, I don't need to take it out. I'm just going to line my ruler up, I'm going to give myself lots of space, and I'm just going to draw a line which is 6 centimetres. And then I'm going to label each vertex A and B, and label the bottom side as 6. It's important to do this as you go along, because otherwise you might make a bit of a mess up if you try and do it all at the end. And it just requires more brain power than is necessary. Okay, so that's true there. I know that AC is 5 centimetres. Sorry, I know C is 5 centimetres away from A, because the side length of AC is 5. And I also know that C is 4 centimetres away from B, because the side length BC is 4 centimetres. So I'm looking for a point that obeys both of these. I'm looking for a point that is both 5 centimetres from A and 4 centimetres from B. So what we could do is draw two circles. We could draw a circle around A that has a radius of 5 and a circle around B that has a radius of 4. And where those circles intersect is the point C, because they're both, that point would then be on a circle which is 5 centimetres from A and 4 centimetres from B. So we're looking at drawing some circles. So to do AC is 5 centimetres, let's start this off. And there we go, so AC is going to be 5. And then what I'm going to do is I'm going to think to myself, where do I expect it to be roughly? Here's 6 centimetres, I'm expecting it to be up here somewhere. I could have it below the line, but I'm going to try and do it above. AC's 5, BC's 4, so I expect it probably to be slightly closer to B than A in terms of lefty-righty. So I don't expect it to be over here, and I don't expect it to be right over here. So actually what I'm going to do is, I'm not going to draw the full circle, I'm just going to draw part of the circle roughly where I think it's going to be. And if I didn't quite get it right, that's okay, I can draw more of my circle afterwards. So there we go, there's my circle, or part of my circle that's 5 centimetres from A. I'm then going to do the same thing from B. I'm going to line my compass up, make sure that it's 4 centimetres. That's right. Your pencil should be a lot sharper than mine. I've left mine blunt because it's better for the video. I'm going to put my compasses on B, and I'm going to draw part of a circle that's 4 centimetres. And you'll notice that these two arcs cross here. And this is the point C, because it's on the arc which is 4 centimetres away from B, and it's also on the arc which is 5 centimetres away from A. So we can just connect this up, connect the vertices by some edges, oopsie daisy, you would want to rub that bit out. I think I have got a rubber actually. It's not very good. If you do make a bit of a mistake, it is sometimes worth just rubbing it out and trying to do that bit again as opposed to being slightly off the mark. There we go, that looks a bit better. So this is 4 centimetres. I do apologise for my hay fever. 4 centimetres. This is 5 centimetres. And it's going to be really tempting to rub these lines out, these arcs. Please don't do that. It's those arcs show the method you use to draw this triangle, and the method's really important. So make sure you leave those arcs in. And one thing you could be asked to do now is measure the angles in here, for instance, and check that they're 180 or something like that. Obviously they are going to be 180 because it's a triangle. But it's one of these things where it could just be a follow-up question saying what's the angle CAB or something, or what's the angle at A. Okay, so that's how we do that using a compass and ruler. And what I'd like you to do now is exercise 12b. Can you do question 1a and question 1b? Once you've done those, can you come back to the video and we'll look at a particular case of a side-side angle. Okay, so pause the video now, have a go at those, and then come back when you're done, please. Okay, so the second one we're going to look at today is a side-side angle. However, it's a particular kind of side-side angle. It's a, here we go, let's have a big long word. It's a hypotenuse side right angle. So what we mean by this is the hypotenuse is the longest side in a triangle, and the side, well, a side is just a side, and then after those two there is going to be a right angle. And it's probably worth mentioning that hypotenuses, they're only defined in right angle triangles. So that's not a word you generally use for the longest side in any triangle, just a right angle triangle. And hopefully it's obvious that a right angle triangle is a triangle which has one right angle in. So let's have a quick go at an example of one of these, or actually let's just draw a picture so we're definitely sure we know what we're talking about. So here's a triangle which has got a right angle in. So there's my right angle, there's my side, there's my hypotenuse. I could have gone the other way around and said side hypotenuse. Notice the hypotenuse is always opposite the right angle. Okay, so here's our example. It says example, construct the triangle DEF so that DF is 4, angle F is 90, and DE is 7. I'm sorry I've bunched this up so much, I'm just trying to get this done on this page, otherwise it's going to cause a bit too much paper wastage. Okay, so you've got two options here. You can either make DE the base or DF the base. And with this particular sort of one, I wouldn't make the longest one the base for a couple of reasons. One, if you think about how this is going to be drawn out, the angle F, the 90 degrees, is attached to this short side here. DF is 4. Angle F isn't on this line DE. Because angle F isn't on this line, then this must be the hypotenuse, because the hypotenuse is always opposite the right angle. So with these sorts of triangles, I'd always do the base being the one that's attached to the right angle. So let's have a go. So I'm going to draw myself a base of 4 centimetres. Here. And now that I've drawn my base, what I can do is grab my protractor and just make sure I get a nice 90-degree angle. If you've got a square book, which most of you, if not all of you, have, then this is relatively easy to do because you can just draw straight up a line. I have no idea how long this next one should be. Oh, I've forgotten to write this in, didn't I? That was a bit silly. DF, 4 centimetres. I've no idea how long DF should be. FE should be. FE is going up here. doesn't tell me anything about FE in the question, so I'm just going to draw a nice long line and accept the fact that some of it's going to be a bit wasted. And then what I'm going to do is set my compass up and think, okay, how long does DE have to be? Well, DE has to be 7. So if I set my compasses up to 7, oops a daisy. There we go. Place my compass point on D, and then I could do a big circle, or I could just think about where do I expect it to be. Well, I expect it to be on this line, so if I just do an arc which crosses the line, where it crosses the line must be E. So you're going to draw a line from E back to D just to finish the triangle off. It's a good idea just to put your ruler on and just double check that the line's actually 7 centimeters. Make sure that your compass didn't slip. We can label that as 7 centimeters, and then a common question could be measure EF. Okay, so if you want to just measure EF as well and just check that we all got the same thing, it's 5.6, 5.7 roughly. Okay, so what I'd like you guys to do now is just finish off question 1, exercise 12b, question 1c. And then after that, can you try and do as much of question 2 to 5 and give yourself, well, let's see, what time are we on? A 30-minute time slot for all that, okay? So do this bit, but afterwards have a go at question 2 to 5, but only a max of 30 minutes, and that will take you up to your hour for the day. Have a great day, and I will speak to you guys again next week. Thank you very much. Bye-bye.